ECUs, they're responsible for braking or for steering or for displaying something on the dashboard, and they know how to do that. And they know what messages they should send and receive, and there is no master saying, wait, should this component really be talking to that component? Making that worse is the fact that the way the CAN protocol works is there is a destination address only in the packet, and we'll see that when we look at the protocol a little bit. So if the braking system sends out information onto the CAN bus, it goes to every single component that's attached to that same CAN bus, and all it has is a destination address, and whatever has that address is expected to handle that message. But there's no source address, so it has no way of knowing where that message came from. It could have come from the braking system, which is where it's expecting it to, or it could have come from your device that you plugged into the OBD2 port, or it could have come from anywhere else. So no authentication, very promiscuous protocol. Every packet generally goes to every device, although they're supposed to ignore anything that's not either broadcast or addressed to them, but they don't have to.
Yeah.
Yes?
Has this changed much over the past 20 years?
No, not at all. CAN was created, I think, by Bosch, maybe in like the 70s or 80s, and the only thing they've really done is they've layered some stuff on top of it to make for longer messages and things. Like, so originally there was only 11-bit CAN identifiers, now there's 11 or 29-bit. There's some of the protocols actually push a bunch of CAN frames together to form bigger packets, kind of like you take Ethernet frames and put together to make an IP packet. But the underlying protocol, no, it hasn't changed. There's discussions that it should be changed, but you know, there's also problems because this was built for speed, right? And in a lot of cases, speed is more important than security in a car. If a message is going to your brakes to say, hit the emergency brakes because my collision detection system saw something, it might be more important to get that message there and not check whether it came from a valid source or not. So they've tended to, I wouldn't even say that they prioritized safety over security, it's more that they didn't really think about security. And they didn't used to have to because you had to be inside the car to send messages like this. So this is a standard CAN frame. You have to memorize all of that in the next 30 seconds or you can't do the lab. Vast majority of this you're not going to see in most CAN packets, so in a minute here I'll go through kind of some typical CAN packets and it'll make a lot more sense because it seems very imposing, especially because the fields in the protocol don't line up necessarily on byte demarcations, boundaries, so you might see, if you're looking at it in hex, it might say something and you're like, oh, okay, I can read that, but really that's two totally different fields. It just happens to be translated to hex that way. But it's usually not as complicated as this would make it seem. So socket CAN is something that was written, I think, by Volkswagen to allow Linux to talk to CAN controllers. And it basically fits in kind of here. The applications can talk to a socket just like they're talking to any other Unix socket-based program, TCP/IP socket or whatever. There's drivers built into Linux now that support this. And then the socket CAN does the necessary magic to take it from a Unix socket to something that can be understood by a CAN controller. You do need a hardware CAN controller to actually talk to other CAN hardware because the Linux kernel doesn't do timing right for some reason, so you do need some sort of chip in there to translate to CAN that would talk to an actual car or something. But we've got some software that John's going to talk about that can fake CAN messages and fake cars and things like that. So I want to go a little bit more into the details of how the CAN protocol works. Like I said, every CAN frame is just a message that gets sent out onto the entire CAN bus. It's got only an identifier as far as where it's going. The most common kinds of CAN messages, and the ones that you'll see the most in the dump that's included on your virtual machine, are diagnostic trouble codes. So this is what mechanics are looking for when they plug in one of their devices. It sends a request. First request it sends is what diagnostic trouble codes do you support, and then what are the values. And those values are going to be engine RPM, oxygen levels, current gas mileage, dozens, probably hundreds of other ones. And so this is request response. The reason I bring this up is a lot of people say, well, why can't they just make this little port in your car read-only? Because that's not how the protocol works. You have to be able to send a request for the data in order to get the data back. So there's a lot of people that are now saying, oh, car cybersecurity, that's a good market. We're going to sell something that's read-only, and that way people will be protected. Snake oil. It will not work. Your car could not meet emissions testing and stuff like that if you cannot write to the port. So as an example of a diagnostic trouble code request and response, what you might have is 7E0, that is the CAN identifier of what is supposed to respond to this request. 01 and then 00, all this is so 7E0 is the target, that's the CAN identifier. Mode 01 is, there's 6 different modes the diagnostic trouble codes can be in. And then 00 is a function, and all that is it says, give me all PIDs that are supported by this car. So the reply that you would get to that is 78, it increases it by 8, just so you know what it's a response from. Then it increases the mode by 40, so you know again which mode it's talking about, so you can kind of match up the responses and requests. 00 is the function that you asked for, and then you would see a whole bunch of hex data, probably in multiple CAN frames, saying which PIDs are supported on that car. And again, we'll see an example of that later on if we look at the CAN dump and stuff. So that's diagnostic trouble codes. Those are relatively benign. They're just asking for data. They can't really do anything. I think the only thing that they can really change is they can turn on and off the malfunction light, the little check engine light. So there's a DTC that can clear that. Other than that, they can't really do anything to your car. Unfortunately, there's all this other CAN traffic which can do things to your car and has virtually no standardization because every manufacturer does it completely differently. Usually what you'll see is something like this example down here. It's pretty similar, but a little bit different. This is a basic one. And as you can see, all those fields that you saw in 2 slides ago, most of that is not in most CAN frames. So this is a simple request. This is using a 29-bit CAN ID, so 24E097. That's the target that is supposed to respond to this CAN packet. The 3 is just that it's 3 bytes data length. And then 0001 FF sent to that address in my Chevy Volt unlocks all the doors. So that's a nice, simple CAN command, but that's an example of what CAN commands are flying through your car at thousands per second all the time. So John is going to go into the software and hardware that we're going to use to play with some of this stuff, but before I do that, does anybody want to ask questions about the not very expert at CAN person who is standing in front of them? Yes.
So this car hacking thing seems to have become more popular just like the past 2 or 3 years.
Mm-hmm.
So if this has been around for 20 years, what's the past 17 years?
Why was there not car hacking then? Because of this. Because before there was no connectivity outside of the car. People could only connect to the CAN bus via serial, via USB in recent years. Now this one's Wi-Fi, there's Bluetooth, there's cellular, there's the infotainment system in the dashboard. It almost always has a cellular chip nowadays. So now cars can be accessed from outside the car, and that's the worst case, up to over the internet. You know, so like the GPAC, they found 700,000 cars that were exposed on the internet that they could get to that open port just over the GSM data network. So that's the problem. And it's going to get worse because they're starting to build these vehicle-to-vehicle and vehicle infrastructure mesh networks. So as you're driving down the road, like if you're coming up to construction, the construction sign is going to send your car a message saying, hey, slow down because you're coming up to a construction zone. And so that's adding another radio. It's called digital short range communications. Yeah. And so that's another radio where you have access from outside the car to inside the car. So it's only going to get worse for now. I am working with a bunch of groups who are trying to make things better, by the way, SAE and Department of Transportation and stuff like that. So there will be improvements, but right now we're kind of an iffy time, I guess.
So as far as the CAN, what about in more automated vehicles like Google's self-driving car? Does it still follow the same procedure, or is there an onboard processor there? I don't know if you know.
Can you repeat the question?
What's that?
Repeat the question.
Oh, so the question was, in like a Google self-driving car, is there more of a centralized brain? And my guess is yes, but I don't know for sure. I would think that there's something that's taking all that sensor input and making it smart decisions based on a variety of input, but I don't know the details of how it works.
Sure.
I'm guessing Google is also upgrading that to things beyond CAN. They're probably using FlexRay and Automotive Ethernet and stuff. We can drive down to the Uber ATC center and see if we can drag any secrets out of them if we want to. But yeah, John.
Yeah, he could talk to me after the meeting. I actually know someone who's working on Google self-driving cars.
Okay.
So
Okay.
he used
So,
to work on our self-driving car at Hack Pittsburgh. So
nice.
yeah.
So we might have in on the Google self-driving car. All right. If there's no other questions, I'll turn it over to John, and he can tell us about all the toys we're playing with tonight.
Cool, thanks, Dan. So I'm just going to really briefly talk about some of the software, some of the hardware that's kind of involved with doing this sort of work. Sort of mostly focused on things that we're going to work with on the lab tonight, but there's also a couple additional toys to play with after the lab. So first off, I'm going to kind of separate this between command line and GUI-driven software. So on the command line, this is kind of the de facto standard, right? CanUtils is an awesome package. It's socket can, user space utilities and tools, and it includes like a dozen or more different command line tools to do different things, right? So you can see can send a packet onto the CAN bus, can generate frames, I should call them CAN frames, to go onto the CAN bus, and that's a little bit closer to fuzzing. Can dump, can sniffer, pretty much what they sound like is what they are. And in the lab tonight, there's a couple different ways of using these tools, and then there's a bit of an explanation around this. There's also can matrix, so there are these things called DBC files, which are essentially these like manufacturer proprietary files on how to format frames on the CAN bus, and they're proprietary, right? So they're expensive. They can't be purchased. These are usually accessed and used by people that are going to be maintaining your car, mechanics and those sorts of people. But there have been periods where those essentially get released, and there are different formats aside from DBC, which people like to use. So this tool is pretty solid at transferring it into, I think, like 6 different types of formats. And the most prominent one that I've found is there's a kayak format. Essentially, this CAN Babel is the same thing as CAN Matrix, except it only goes DBC to the kayak. So the CAN Matrix definitely appears to be more flexible in that regard. There's also socket CAN D and CAN iBus. And so I'm just gonna kind of buzz through these really quickly. But what's cool about socket CAN D is it allows you remote access to CAN network. So say I have my laptop and it's connected to a car, and there's a network interface where this is like on the Wi-Fi or something. I can go to another device and send network packets to my box, and it will then relay them onto the CAN and then relay the responses back. And this isn't just good to get more remote access, but it also gives you many-to-one access. So you could have 6 people accessing that one CAN bus. And if I had more time and money, that's the kind of thing that we would have been doing tonight with a car parked outside. If I could have just bought a car and put it out there, that's essentially the tool that I'd be using, and the tool that I've seen mentioned a lot of time in different papers to get that many-to-one access to the CAN bus. And CAN bus can do something similar. So like I mentioned, there's a couple GUI-based software apps. So Kayak, CANTACT app, and CAN bus triple are the first couple I'll talk about. Kayak we'll do some really cool like overlays on maps, GPS information, and I mean it's pretty much what you expect is to view what's happening in a car, right? It's gonna take the CAN information and just throw it out on a couple different plots and different graphs and things like that. CANTACT app, pretty similar. It can receive and it can also record. CAN bus triple, I haven't played with this, but I wanted to give this kind of an honorable mention because there's also a hardware platform behind this, which I'll show you a little bit later. It's pretty cheap. I haven't been able to actually buy one yet, but I've been waiting for them to come back in stock so I could buy it. I was hoping to have one for tonight, but it has a pretty solid community around it, and the app from the screenshots and the website looks pretty spectacular. So I'm just going to give that one an honorable mention. And then Wireshark, everybody's tried and true. You gotta love Wireshark. Yes, it can do CAN. So yeah, you can just monitor a CAN bus. You can record with it. You can do all kinds of cool stuff, and that's in the lab. And then there's IC Sim, which is an instrument cluster simulator, which I thought was really cool because it shows you the instrument cluster, so to show like your speedometer, right? And then there's a control for that, and you can actually plug in a Xbox controller and actually control things, accelerate, decelerate, turn left, turn right. And that's cool, you can make the dials change on the instrument cluster. But what's more cool is if at the same time that you're doing that, you open up like CAN dump or something and you monitor the CAN bus, you can actually see that this isn't just making it move by a little bit, it's actually sending those CAN buses, the CAN packets onto the CAN frames onto the bus and then pulling them back off. So you can monitor all this stuff, you can do replays, you can see what would happen to an instrument cluster if you were to fuzz it, right? And there's also another tool which I didn't mention but is in the lab called VirCar, it's virtual car, and in that case you can actually blow up the engine if you send it the right CAN frames. So it's just kind of another way to illustrate, what could happen if you actually plugged in to a CAN bus. And so I'm going to talk about some hardware here. I have a couple examples with me. So this is a CAN Tact. That's a picture of one. This is one in real life. It works pretty well. It works pretty well as in compatibility wise. I have heard comments that it may have a significant drop rate, so you may have to do things multiple times and it may be somewhat unreliable, but it has a couple cool features which I will release these slides. If you click on that link, you can find where I wasn't able to find anything on the website about these extra features, but that's a presentation and it goes to a point in the presentation where he talks about his hardware device. And there's things on here like resistors to terminate the CAN bus, which is cool, so you don't actually have to have a terminated CAN bus. This can terminate for you. And these pins right here actually allow you to reconfigure the pinouts for the DB9. So if you know much about serial connections, there's multiple ways to pin these things out. And if you have like just a regular serial cable like this, it can have a variety of different ways those pins connect to the CAN, and that allows you to configure it. So whatever setup you have, you can make it work with that, which is really cool. Again, so this is the CAN bus triple. It's out of stock. The price might have actually dropped too, I'm not sure, but it looks like that. There's also an aluminum case one, and there's a pretty big community around it, and the applications and stuff go pretty far. It's very interesting stuff. And then this isn't really hardware, but I wanted to mention the Car Hacker's Handbook. So I know at least one or two people in this room have read this or parts of it. This is to be given away tonight. Prove yourself. That's all I have to say. If you can show us something interesting, you can have this book. Or a strong amount of interest in the topic, you can have that book. But yeah, so it's $49.95. You get the print book and you'll get the ebook as well. And if you just spend the $40, you just get the ebook. So you can have the paper version for proving yourself. Or you can just go to Car Hacking on New Search. Any questions about the hardware software? I really didn't cover that much, but and a lot of that sort of stuff. If you want to get hands-on with it, we'll do that all in the lab. Cool.
I have a question.
What's up?
How do you know what serial rate you're supposed to configure the interface for the read stuff?
You guess.
Oh, okay.
You essentially guess, yeah. So there are some tools that will just like kind of round robin and just go from one to the other, like go to 500K and 125K and whatever all the other numbers are. You pretty much guess, right?
Yep.
Yeah. So that's pretty much what I did, and it worked. Trial and error. It's unfortunate that it has to be that way. A lot of this stuff is actually that way. If you want to figure out what CAN message does what on the CAN bus, and we'll actually try to do a little bit of demo of that later. You're going to just trial and error and filter through a bunch of stuff on the bus because it's very, very noisy. You can see that if you look at the CAN recording and also if you do some of the CAN replay stuff. So the lab, just a couple quick discussions. So we get a couple people that came in late. Does everybody have the VM? If you don't have the VM, put your hand up. 2 people, okay. So there's a USB drive. Do you still have that?
Yeah.
Okay. Can we please get that to them? I have a bunch more. It's also on a CIFS share, SFTP. It's on the internet. Try to make it as available as possible. Let me know if anybody has any issues with the VM as well. Are you still having issues? You're good. Okay, good. You use VMware Player? Use VMware Player. He was using VirtualBox, had issues. Other people have used VirtualBox with success, but VMware Player seems to be a constant good.
John, can we get another USB stick? I think we have
Yes,
one
we
more.
can get a second USB stick. Yeah. Would you mind passing that over? Sure. All of those have it on there, so. So there's a couple objectives for what we're trying to do with the lab. So there's three main things. First, we want to kind of set up the VM that you can use to interface and write to a CAN bus, read from a CAN bus. So pretty much all of the lab is for virtual CAN, but it translates one-to-one. You know, instead of vCAN 0, you do CAN 0, and it's pretty much the same thing as long as you have, like we were talking about earlier, your baud rate set up correctly. We also want to kind of I was hoping that we could familiarize ourselves with some fundamental CAN tools, the socket CAN suite that I mentioned earlier, a couple of the GUI tools, that sort of thing. And then interface with a virtual car CAN bus. So there is a virtual car that you can pipe that will make a VirCar interface, and you can send things to and from that as if it was an actual car, and you can see what happens. You can fuzz it without worrying that you're going to break the car, blow up an engine, anything like that. So lab setup, most of you guys already have this because you have the VM. The VM is right there. But if you don't, you can just run this command if you have git, and then you'll just have to cd into the lab, run kickstart, and run git pull. So there's been a couple additions to the GitHub repo, the branch, since I made the VM. So I made the additions today. So if you do this, if you run these three commands, then you'll get the most updated version. It also, the kickstart script is kind of nice because it'll set up things like your interface. It'll set up the interface if you have physical or virtual. I'm assuming most people are going to do virtual. So whenever it says, are you going to use hardware, say no. There you go. It'll set up everything for you. If you get some error messages, let me know. But at the end, it should say, you know, you're good. You know, you got through all these steps and it's successful. Again, the username is carhacks, H-A-X, capital T, at symbol, SSWORD for the password. That is also up there in the top right, if you forget. Or you can ask me. So I will go back to the slide in a second so that you have this as a reference. But essentially, just log in, go to Desktop Lab, and then set up script, kickstart, and that should take a few minutes. So there's three main folders within here. I just wanted to talk about them briefly. Setup. So in the setup directory is where the scripts are to set this up. If you were to just download a plain Jane Kali 2016.1 and you run that, it'll take like an hour and a half, but it'll set everything up, compile things. It'll do the Maven setup. Everything will get set up, and it'll tell you if it had errors. Tutorials, so here's where the actual labs are. There are beginner ones and intermediate ones. There are read-only ones and write ones. The reason why I split that out is because if you actually wanted to do this on a car, just follow, you know, you could, with caution, you know, and I make no decree that this will not hurt your car, so, you know, this is of your own volition, but presumably the read-only stuff wouldn't cause damage to the CAN bus, or to the car. And then external, so I linked to a bunch of external projects, so I just put them under one folder. Those are all sub-modules in Git, so whenever you're pulling it, you have to make sure you have that -- recursive, or else it will just be empty folders. That is all I've got, so I am going to leave this slide up, pause the recording, and kind of come around and help people with this lab. If people seem to be having a tough time with it, I can do some demonstrations on the actual VM. I have it all set up here. And then, you know, maybe in a little bit, I don't know how long, but Dan will be able to set up, show us a bit of a demo, right? Yeah, cool.
We have to go outside to my car to do it.
Yeah, it's going to be like a close-up and personal outside. Hopefully it's not raining. I don't think it is. Demonstration. So anyways, that's about it. I'm going to be walking around. Let me know if you guys have any issues or questions or concerns.